Okay, so now we are going to talk about the aggregation in MongoDB. So aggregation framework is basically this. It's kind of similar to the aggregation in SQL, but it's slightly different because in MongoDB, the aggregation is about transforming and combining documents in a collection based on what you specify. In aggregation function in MongoDB, you can use it like this. So first of all, you specify the database, and then you specify the collection, which you want to do aggregation, and you specify the aggregate function. And here, because it's a function, we use this parenthesis here, and inside you kind of provide multiple operation you want to perform. So you provide a list of operations here. So by doing this, in MongoDB, you are creating a pipeline that processes a stream of documents through several operations one by one. So that's how MongoDB aggregation frameworks work. And the operation you can include here is something like this: filtering, projecting, grouping, sorting, limiting, and skipping. So we are going to talk about this later today. So here, if you specify like this, so if you specify a list of operation inside the aggregation framework, then what happens is this: you have a collection. So inside the collection, you have a lot of documents. So this document will be sent to your first operation. So this operator will perform and process documents, and the results will be sent to second operation. And this operator will perform the performing and process, and then results will be sent to the next operator. So the next operator also process the documents, and then it will finally go back to you as a final result. So that's how the aggregation works in the MongoDB. So let's talk about one by one which operator you are able to utilize in aggregation. So first operator is a filtering. So basically it's a match operator. So match operator is exactly same as a query. So earlier and the last time we talked about the query function in MongoDB and how to design query. You can use all those query here. So basically you can specify match operator and you specify the query we covered in this class. If you do that, it will filter documents from a collection and select a subset of documents that match with your query. So you can use all query operators we covered so far in this class here in this part. So here's one example. So let's say that we want to select all the zip code with a population more than 100,000. Then we can design like this. So for example, if we remind you briefly, we have this city collection here. If I right click and if I click view documents, we can see the city collection here. And every city collection contains ID, which is a zip code field, and city information, the GPS information, longitude and latitude, and population information and state information. So we want to select all the zip code with the population more than 100,000, then we have to compare this population field. So here, what we can design is something like this. We can use match operator, and we can specify the query. The query is that population should be greater than 100,000. Like this. So this part is basically the query we covered previously. It's exactly the same. So here in MongoDB, if we try this, we can say that db.city aggregate function, and we have to specify a list of operator. But in this case, we only use one operator, match. The match operator will be population should be greater than 100,000. Like this. If I perform this query, here's the result. There are 4 zip code that has a population more than 100,000, like this. So that's how the match operator works. So basically you specify query to select a certain document from your collection. Another operator you can utilize is a project operator. So it's here. So you can specify the project operator and you specify the expression. So you can use a project operator to extract or rename the fields. So basically, in this case, it's similar to the returning rules, which we covered in the query. And also you can do some perform operations on the fields. So actually it's more powerful than normal query, which you use in the read function. Type of expression you can utilize are these things: pipeline expression, mathematical, date, string, logical expression. So let's talk one by one. What are those things? First of all, pipeline expression, which is similar to returning rules in the query. Basically, you can decide whether to include the field or exclude the field. If you want to include the field in the operation, then you can specify field name and 1 to include that field in the returned result. If you specify 0, that field will be excluded in the returned result. And when you're using pipeline expression and other expression in MongoDB in aggregation, you can use this format to refer to and specify the existing field. So in a document, you have a certain field and you want to refer to that, then you can specify existing field name here and put a $sign in the front and wrap this by double quote. Then this means that it refers to the value stored in the existing field in a document. So why you need this? You can use it for this kind of purpose. You can rename the field. If you want to rename the field, you can specify the new field name, which you want to have, and you can specify the old existing field name. So old existing field will be renamed into the new field name in the returned result. So it will only affect the returned result. However, it does not affect the original document stored in your collection. So original documents stored in your collection still will have their original field name. So let's try this practice. So let's just say that we want to select all the zip code with a population more than 100,000. So this one, we did it earlier. We can use match operator to perform this task. And we also want to make sure that we rename ID field into zip code field and return only zip code and population information. So this can be done by project operator using pipeline expression. So let's try. So this one, first of all, we use the match operator like what we did earlier. So we have a match. And earlier we used the population. Population should be greater than 100,000. So after this first operator, we put comma and we go to the second operator. The second operator will be project. We have a project operator, and then we rename the field first. We will have a new field called zip code. It will replace the ID field. And then we don't want to show original ID field in the returned result, but we want to show additionally population field like this. So we can try this. So go back to the MongoDB, and here in the CD collection, so we can try that. Oh, so actually, yeah, we already have this match operator. So after that, we can simply add project operator. So project operator, zip code, will replace ID field, and original ID field we don't want to show in the result, and the population field we want to show in the result like this. So if I perform this, here's the result. So again, because there are only 4 zip codes that has more than population more than 100,000, we will see 4 documents here. For each document, we have a zip code field and population field only. Other fields are all gone like this. So that's it. That's the pipeline expression here. Okay, so also you can use the mathematical expression. You can specify the new field which will contain the value from your mathematical expression, and then you can specify mathematical expression you want. So you can manipulate any numeric values stored inside your document. So mathematical expression you can use are add operator, subtract operator, multiply, divide, mod operator. So those are like basic thing. Add operator, you can specify multiple elements in a list. Then all these elements will be summed up and it will be saved into new field. Subtract, you can put a list of 2 elements, then it will calculate expression 1 minus expression 2, and the result will be saved into new field. For multiply operator, you will have a list of multiple expressions here. It will be all multiplied together, and the result will be saved into new field. Divide operator, similar, expression 1, expression 2 as a list. Expression 1 over expression 2 will be calculated, and the result will be saved in the new field. There's also mod operator. So you can also specify 2 value inside the list. It will return the remainder of dividing the first by the second expression. So those are basic mathematical expression you are able to utilize in the MongoDB. So here is a very simple exercise. So you can try. I just show you the solution, and you can try this by yourself later. So currently, what we do is this. So we are making staff collection. Inside the staff collection, we are adding these 2 documents. First document is about name Tom, salary is 80K, bonus is 20K. Second document is about name Jane, Jane's salary is 70K, bonus is 25K. So if you sum up salary and bonus together, if you add these 2 values, it will become their total pay. So we want to calculate the total pay of each staff. Then we can use a mathematical expression using project operator. So we specify database, staff collection, aggregate function, and we specify a list of operators here. And we only use one operator, which is project operator. So use project operator here. And then we specify total pay. So we make a new field to contain total pay information. And this field value will be calculated by add operator. So what we have to add? We have to add salary and bonus. So this is an existing field inside the document. So after add operator, we have to put a list of elements. First element will be value stored in the existing field. So salary field and bonus field, like this. And then close the bracket here, and that's it. So basically, using the project operator, we'll calculate salary plus bonus by using add operator and save it into total pay. So that's it. So that's how you can design and solve this question using project operator using mathematical expression. So this you can try later by yourself and see how it works. Other expression you can utilize is a date expression. So you can specify the new field which will have the information number and specify date operator and specify the date field. Then either extract date and time related number from date type field. So from this data field, we extract a certain number and save it into the new field. So data operator will receive data as an input and return the number as a result. So what kind of operator you can use are this year operator, month operator, week operator. So from a certain date, it will extract the current year, current month, and current week and save it as a number. Or we can use a day of month, day of week, day of year operator. Similar. Also, we have hour, minute, second operator, which we can extract the number from the time data. So in the next page, we have this exercise again. So again, you can try this by yourself later. I'll just explain how this works and show you the solution here. So here, first of all, we are in the staff collection, we are adding these two documents again. First document is for Tom, and we have hired the field, and we use new date function here. So if you use new date function, what's happening is that the current date and time will be retrieved and saved into hired field when this document is added into staff collection. So current time will be stored inside the hired field. For Jane, same. So after a few minutes, if you type this code, the new document for Jane and the hired field, the current date will be stored and saved inside staff collection. What we want to do here is we want to know what is the month and the day of each staff hired. So we can use the aggregate function here. So db, the staff collection aggregate function, and we put a list of the operator, and only one operator we are going to use. The operator is basically project operator in this case. So we use a project. And then what we want to do is that we want to extract months. So how to extract months? We can use month operator. So we can extract the month number from the date. And where the hired date is saved, which is saved into hired field. So we have to refer to the existing hired field like this. So we extract month from hired field and save it into month field. And then we also want to save day. So we use day of month operator on hired field. And then close this, like this. Then we also extract the current day of month from the hired date field, and we save it into day field like this. So after performing this in the returned results, for every document, we'll have a month information and the day information as a number, which are both extracted from hired existing field. And the next expression I want to briefly talk about is a string expression. So you can also manipulate string characters which you have in the document. So you can, the format is similar. You can specify the new field which will have the new string information, and you can specify the string expression here. String expression, you can use these things. They're just substring, so you can extract a certain part of a string and save it into the field. So in this one, you can specify 3 elements in a list. So expression, start, and number. Then it will return the number of characters starting from the status position from string expression. And there's also concat operator. And this operator, you can specify a multiple string elements inside the list. Then simply, this operator will combine all these string and make it as one long string and save it here into new field. There's also 2 lower operator, 2 upper operator, which is changing string expression into lowercase or uppercase string. So here's one example. So we want to select all the zip codes with a population more than 100,000. So this is again, the match operator can do this job. And we want to return each address information with the following format, cd, state. So we want to make a new text. Then we can do this by using project operator with the concat operator. So concat operator, again, is this one. So we can put all the strings together and make it as one string. So basically using the concat operator, we can extract the cd information, state information from the document and we can put them together. So that's what we want to do here. So to do this, we can specify database, .cd collection, aggregate function, and specify a list of operator. The first operator is the match operator, which we utilized earlier. So exactly same. So on the match operator, what we want to use as query is that population should be greater than 100,000. And then now, after we extract those documents, those zip code with a population more than 100,000, we want to return their address information based on CD state. So we want to know which CD, which state it's coming from. Then we can use project operator here, and we can make address field. Address field will be concat by CD existing field and comma state existing field. Like this. So we can do this. So extract the CD field, state field, and concat their information together into this CD, state format. So we can try this. So this one, let's just see how it works. So here, again, we have this match operator, which we made earlier again. And then in the next one, we can use the project operator. Address should be concated by using concat operator. The CD state field's value should be concatenated together like this. And then if I perform this query, here is the result. So again, we have 4 zip codes. And then now you can see that now we have address field. So New York, NY, New York, NY, Brooklyn, NY, and Chicago, and IR, like this. So that's it. That's how we can utilize this project operator with a string expression. Other expression we can use are these things. There's also logical expression you can utilize. So you can specify a new field. You can use logical expression here. There's a CMP comparison operator, and then you can specify 2 elements inside the list. And then if these 2 elements are same, it will return 0. If a second expression is bigger, it will return negative number. If a first expression is bigger, it will return positive number. Also, there's a string case comparison. It's for the string character. So you can specify 2 string elements inside the list. It's similar to the comparison operator in terms of how they work, but it's for case insensitive comparison for strings. There's also conditional operator. So it's similar to what you did before. So basically, you can specify conditional operator and you can specify 2 elements in a list. Then it will compare these 2 elements and it will return the results as true or false. Comparison operator you can utilize are these things: equality, not equal, greater than, or equal, less than, or equal. So basically you can use every conditional operator we used in the query before. It will perform comparison and it will return true or false value. Other logical operator are these things. It's exactly the same as what we used in the query part. So AND operator, you can specify multiple elements in a list. OR operator, you can specify multiple elements in a list. NOT operator with 1 expression. Conditional operator. So this conditional operator, if you are familiar with the programming language, it's similar to if. So in some programming language, they use if-then statement. In Python, we have this code. So in the Python, if we use if, we have if, and we have an expression here. And if the expression is true, we will go here and return this result, true expression. If it's not true, expression is wrong, then we go to the else part and we return false expression result. So that's how the if statement works in programming language. It's exactly the same here. So basically, you specify 3 expression here. First one is expression here for the comparison. So if this is true, we will return and do this part, true expression. If this is false, we'll do this false expression part. So it's exactly the same for that. So that's the conditional operator, and that's the all logical expression we can utilize. For the string case comparison, it's the same as the comparison, but it's used for string. So if they are same, if string 1 and string 2 are same, it will return 0. If string 2 is bigger than string 1, what it means is something like this. String 1 is A, string B is B. Then we consider string B is bigger, string 2 is bigger. Then it will return negative number. If it's like B and A. So first string is bigger, then it will return positive number. And then if first string and the second string is the same, it will return 0. So it's exactly same as a comparison operator, but just for the comparing 2 different strings. So that's it. So you can, if you try, it will be more easier to understand. You can just try different things and see how it works. So there are too many operators. So here I cannot show everything one by one, but all the information of the syntax is here. So you can try something and see how it works. And the next one is this aggregation. So it's the grouping, basically. It's the group operator. So for this one, syntax is like this. You can specify the group operator here, and here in this documented structure, body structure, you can specify here the grouping rule based on what you want to make a group. And here you specify the combining rule, how to calculate aggregation. So this is similar to aggregation we did in the SQL. So we group documents by condition you specify here, and we combine their value based on combining rule you specify here. So let's talk about how you can determine the grouping first. So to determine the grouping, you have to determine the group ID. So similar to, again, SQL. In the relational database in MySQL, when we use the aggregation, we determine the group ID first. Same here. In this case, we have to determine group ID, and you can refer to an existing field. Then the value stored in the existing field will be used to make a group ID. For the combining rule, here is where you specify how you want to calculate information on each group. So on each group, you specify a field, what field you want to create to store information from the aggregation. You specify the combining operator here, you specify the expression. So either perform combining operator on expression for each group. So expression can be a value or an existing field. Combining operator, here you can utilize these things. Summation, average, max, mean, first to last. First and last are for the list data type. So it will return total, average, greatest, smallest, first or last value from documents in each group. So it's when there's a list of documents. So there's also add to set operator, push operator. So 2 operators are available for array manipulation too. So you can make a list or make a set by using add to set or push operator on each group. That's also possible. So here's one example here. So let's try this together. So let's say that we want to calculate how many zip codes exist in each state. Then here, based on this question, what we have to make as a group is a state, because in each state, we want to calculate information. So in each state should be grouping and how many zip codes exist. So this is the combining, basically. We have to define combining rule to calculate this information. So if we use the group operator, we can do this. database.cd collection aggregate function, just like usual. And inside the aggregate function, we list number of operator. And in this case, we'll just use one operator, which is a group operator. So we use group operator. And inside the group operator, the first one we need to do is just specifying grouping. So grouping, we have to define group ID. So group ID will be based on state. Each state will be a group. And state information is currently stored inside the state field. So we refer to existing state field like this. So grouping is done. So this part is basically grouping. So we are done. And then we have to specify combining rule, how we want to calculate this information. So how we calculate? First of all, we have to calculate how many zip codes exist in each state. So we first make a field to store the aggregation result, number zip. So number of zips will include how many zip code. And how to calculate? Simply summing up number 1 for each document in a group. And then and finish grouping. So basically this is one more. Yeah. So this is basically combining rule here. How many zip codes exist? So what's happening is this. So there are many documents in a collection in our CD collection here. So some of the documents will belong to, so they will first grouped based on the ID. So this belong to California. This belong to New York. So this belong to Illinois, something like this. So based on the state, they will be grouped. And then for each group, we calculate this number of zip codes. And we did a summation of 1. So for every document, it will be 1, 1, 1, 1. So we sum up this number, then it will be CA2. Here, NY2, IL1, like this. So that's how this works. So this grouping operator is exactly the same as how the relational database does aggregation. So you can think about that. And let me just show you how this works. So here in the cd.aggregate function, we can use the group operator. For group ID, we can use state, existing field value, and then we can calculate number of zip code based on summing up number 1 for each document belongs to that group. And then that's it. So if I perform this code, here's the information. So there are some like NA and AR which we don't really need are there too, but the main thing is NY, IL, CA, TX. And NY, we have 1,595 zip code. So number of zip is this number. IL, Illinois, we have 1,200 zip code. CA, we have 1,500. Texas, we have 1,600 zip code like this. Okay, so that's the grouping of group operator. So next one is an unwind operator. So unwind operator is just slightly different things. So here we specify unwind operator and we specify the existing field. So what's happening is this existing field should be a list. So it contains multiple elements. And then it will turn elements in list into separate document. So each element will become separate documents. So let's just say that we have this one. So again, I'll not try this, but you can try by yourself later at your home. I'll just explain how this works. So we prepare this data. So we make a blog collection and I insert this one document here. So one document. So this document is written by the user key and the post is about hello world. And it has a comments field. The comments field is currently a list of 2 documents. There are 2 documents embedded here. first document is first embedded document here is user Tom text nice post. The second embedded document here is by user Jenny text cool like this. So there are two embedded documents in this list data type. What we want to do is this. We want to find all comments made by Tom. So we don't care about main documents information. We don't care about this. And we just want to look at the comments field. And there are multiple comments. At that time, we want to look at each comment. We want to find this comment made by Tom only. That's what we want to do. Then in this case, we can design the aggregate code by using project and unwind operator and basically multiple operator together. So first of all, we don't care about this information. We only care about the comments field. We first use project operator to exclude other parts. We only want to include comments field. So we include the comments field in the return result. We exclude all the other parts. And then only this part will be left, comment field. We use now unwind operator to make each element into a separate document. So we specify comments like this. So the comments list of elements will be separate documents. And lastly, we want to find all comments made by Tom. So here we use now match operator to select comments user is Tom. Like this. So you can try this later. If you try this, basically it will return only this document as a result because only that comment is written by Tom. So here there are like multiple like brackets. So that I received the discussion last time. So there is like this bracket, and this bracket. So they are all different. So this bracket, we use this for function when we refer to function. So it's something like this. After every function, we have this bracket. So like after read function, we have this. After update function, we have this. And after aggregate function, we have this. So after function, we have this open bracket, open parenthesis, and close parenthesis. So this bracket is called parenthesis. So we use it for we use it after function. And the second bracket, this is the list data type basically. So when you have multiple elements inside a list, we represent that list by using this bracket. So in aggregate code, for example, aggregate function, inside the function, we have to specify multiple operator. So each element is operator. So we use this list format. And also here in the comments field, we have two elements inside the list. So we use this bracket. And the last one is for document, basically, to represent the document structure and also query or operator in MongoDB. So you know this, right? So when we define the document, we did this, like we specify this as a start of document, we specify this as end of document. So usually when we define document, we have this start and end, and inside here we have a field and the value. And we have another field and the value like this. So this represents a document. And also this represents a query too. So in a query, we start with this and we end with this like this. So that's the main difference between these different brackets. So that's something you may think of. So if we, especially again, if it's your first time, using programming code a lot, and getting into MongoDB for the first time, then it might be a little bit confusing because there are too many different brackets. But if you just practice a lot, and if you just type these things on the slide at home by yourself when you have time, then you will get more familiar with this difference. So this is for function, this is for list, this is for document and query. So there are specifically different roles assigned to each one. So yeah, by more exercise, you will get more familiarized with this kind of a thing. Okay, so other aggregation operation we can utilize are this. There are some optional operators like a sort operator, limit operator, Sskip operator, out operator. So sort operator, if you use it, it will sort the query results, aggregation results based on what you specify here. So you can specify a field and one, another field and -1 like this. Then it will be sorted based on field 1. For the documents having the same field 1, it will be sorted based on field 2 like this. So you can define hierarchy of sorting order. And when you specify 1 or -1, it means sorting based on ascending order or descending order. So you can try this later by yourself. Also, there's a limit operator. You can specify limit and number. Then it will return the first number of documents you specify as a result. Also, there's a skip and number. Then it will skip the first number of documents you specify in the result. And there's an out operator, and you can specify the new collection name here. Then what's going to happen is that the results of your aggregation function, those document results, will be saved as a new collection. So that's the out operator here. So let's think about this aggregation function. So let's say that we want to find out top 5 city which has the largest population in our data set. So first of all, what we have to do is that we have to make a group because we have to calculate population for each group, which means that each city in this case. So we use db city collection aggregate function, and we specify a list of operator. The first operator we are going to use here is the group operator. And if you use group operator, you have to define the group ID. The group ID we are going to use is a city basically, but it's possible you may have the same city name across different state. So we are going to use combination of a city and state. To make that as a combination, we will use concat string operator. And here for the group name, basically we are going to use city name, comma, state name combined together by using concat operator. So we determined group ID here. And then next we have to define the combining rule, how to calculate total population for each city. So total population will be calculated by sum operator on population value of each document. And then that's it. So basically for each group, there is a population value on each document. So we are going to sum them up and we are going to save it into total population field like this. So that's the grouping. So we are done with the grouping. And next, we want to find out top 5 city which has the largest population. So we have to sort it based on the total population. So first, using the sort operator, we sort based on total population. We sort based on descending order. So the highest population city will be shown on the highest, on the first. And then we only care about top 5 city. So we use now limit operator to choose top 5 city like this. So I can show you this really quickly. So this one here, I can type this code db cd aggregate function and specify a list of operator. The first operator we are going to use is a group operator. ID field, we use concat operator and combine city and state. Like this. And then we specify the total population, how to combine information. So we use a sum operator, summing up all the population field information. And then we use sort operator to sort based on total population. And then use the limit operator to show only top 5 results. So if I perform this, here is the result basically. So we can see that what are top 5 city based on total population living in the city. So Chicago has the highest population of 2.45 million. Brooklyn has the population of 2.3 million. LA has a population of 2.1 million. Houston 2.09 million. And New York has a population of 1.47 million, given our data set on what we have, basically. So that's the result of this exercise 1. And next one. So now let's say that we want to find out population of the city Chicago in state Illinois. So we don't care about other city. We only want to know what is the population of a city Chicago in state Illinois. Then we can do the same thing. So basically we can keep this part, right? So this part is the part that calculate total population of each city. So we can keep that. So we can type the same thing. So let me do it really quick. So ID should be concat $city and state. And then total population should be like this. So we calculate the same thing. So it's exactly the same. So this part, we put it here. So basically this part, what they do is that for each city in a state, we calculate total population. But we want to know total population of a city, Chicago or Illinois. So simply we use match operator to find information of Chicago, Illinois, like this. So we can do this. So if we do this in the MongoDB, then basically we can do this. So we have this query, but let me open one more query here. So I can copy this here. And the first part is the same. In the second part here, instead of this, I can simply type match. And the group ID should be Chicago, Illinois, like this. So if I perform this code here, the information is here. For Chicago, Illinois, we have total population of 2.45 million, like this. So that's how you can get answer. But this is actually not a good query. So there is a better design. So this is one way you can design. Another way is that because we only care about Chicago, Illinois, instead of calculating total population for every city and then choose Chicago, instead of that, we can put this match first. We can first filter document the zip code that belongs to Chicago, Illinois, and then we can calculate total population. That's another way. So instead of this, we can do this. We can use match operator first. So we select city, Chicago, and state, Illinois. So we can do that. So we first select those zip code documents that belong to Chicago, Illinois, and then we use the group operator later to calculate the total population. So in this case, for ID, we can just, we can use the same thing. We can use the concat and city state. And then we can have the total population summing up over the population like this. So basically, it's exactly the same as this one. So here, there's a group operator and match operator. So this one is first, and this one is second. So we simply change the order. So we made a match operator comes first, and group operator comes later. So it will give you exactly the same results if you try. So here, I can try this first code, and then I can try the second code here. So just I move this into here. But because there's no group ID, I have to match based on city, Chicago, state, Illinois, like this. So if I perform these two codes, okay, there's a so there is oh yeah, I'm missing colon here. So if I perform this, okay, here's the results. So you can see that the first query and the second query, first aggregation code, second aggregation code gives you exactly the same results. Right, exactly same results. But there's a difference between these two. The difference is this. So I put that the second code is the smart code and the first code is a naive code. There's a reason. It's because of the time. How many times it takes for each of the code to give you the result. The smart aggregation code is almost 4 times faster than naive aggregation code. So you can see that the time it took to calculate the information is different. It's also same in our case. So if I look at my screen here, so here it took 0.02 seconds for the first code. Second code, it took 0.005 seconds. So second code was much faster. And there's a reason why it happens like that. It's because of this. In smart code, which I showed later, the documents were filtered first by matching operator. In naive code, all documents were used to calculate group value, and then results were filtered later. So basically, in the first code, in the naive code, I calculated the total population for every city, and then we choose the Chicago. In the second code, in the smart code, I filtered Chicago document first, and I only calculate total population for Chicago documents only. So there are much less number of documents to calculate information for the smart code. So that's why. So to speed up aggregation, you always have to prepare less documents first. If it's possible, that is better. Then you will have a speed and performance boost. So always filter first. So this is important because again, I mentioned about this before. The reason why we are using this kind of system like NoSQL or big data technology is because we want to increase performance. We want things to be done fast. So even when you design document structure, you have to be careful about how your document structure can guarantee good performance. Same for the query. When you design query, like aggregation, you have to think about whether your query code is able to give you a good performance. So that's very important things. You have to already think about the performance boost and how the performance and the speed will vary depending on how you design the documents and the query.